Hey guys, today we're going to talk about algebraic properties. So for homework, you got the pink sheet after you finished today's test, and then you also got the homework. So I'm just going to go through the pink sheet. It's actually white on here, but I'm just going to try to explain some of the properties if you're having a hard time understanding the pink sheet. So every year you actually learn some properties. In the past, you've learned associative, commutative, identity, inverse, distributive. We're going to add a few new properties in this year, and we're going to also refer to the ones that we've learned in the past. And this year we're actually going to, when we solve equations, we're going to try to demonstrate what property we're actually using. So hopefully this year it will make more sense as to why we have these properties. Okay, and with higher maths and when you get into geometry and all your higher maths, you can do algebraic proofs, and a lot of these will use the field properties and the properties of equality and inequality. So let's start out with the multiplicative property of 0. Okay, that's actually a very easy property. It just says that if you take any number, times 4 times 0, it's going to equal 0. So any number times 0 is 0. If you take a variable and you multiply it by 0, you're still going to get 0. Okay, so that's the multiplicative property of 0. Okay, the zero product property is a little bit different. Okay, it's basically saying that if you have A times B and that equals 0, then you know that A has to either be equal to 0 or B has to be equal to 0. Okay, because, or both of them, they could both be 0, but if A or B is any other number, there's no way you can get 0. So that's the zero product property. Okay, the reflexive property is new this year, okay, and it is actually a very simple property. It simply states that A equals A. So if you think about it, A equals A, and we're going to use this when we do our check steps when we're solving equations. If you end up with an answer and it says 6 equals 6, well, is that true? Yes, it is. Okay, 6 equals 6, A equals A. That's an example of the reflexive property. Okay, the symmetric property actually is important. It looks like almost like the commutative property. It looks like you're switching the order around, but it's not quite. The symmetric property, and this is important, actually has in it the words if and then. Okay, so this is really important. It has to have the words if and then in there. So if we said that A is equal to B, if A is equal to B, then we can say that B is equal to A. We can flip the order around. So say I said if X is equal to 6, then we can say that 6 is equal to X. And if you look at it, you can see it's kind of symmetric here. Okay, A is equal to B, B is equal to A, so it is the symmetric property. Okay, so that's the symmetric property. Let's write that down here. All right, the last new property that we're going to learn this year is called the transitive property. Okay, and the transitive property, actually we've got our keywords here again that we really have to look for. We have an if, an and then we have a then. Okay, so if, and then implies the transitive property, and what that means is it's saying if A is equal to B and our B happens to be equal to C, okay, then that implies our A is equal to our C. So the A is equal to B, B is equal to C, then A is going to be equal to C. That would be the transitive property. And that also works with inequalities, meaning if your A is greater than B and your B is greater than C, then we can say that A is greater than C. So it's like transferring it over. So think of transferring or transitive. And the same works for less than. If A is less than B and B is less than C, then A is going to be less than C. Okay, so that's the transitive property. Okay, so some of the old properties that we've learned in the past, oh, actually these are new properties too, but we're going to talk about these later when we actually solve equations. So these are properties of addition, subtraction, multiplication, and division. And we're going to talk about them as we solve equations. So I'm going to come back to this when we do our equations unit. But basically it's saying that if we have A is equal to B, then we can take A and add C to one side, and then it would be equal to B plus C. This is going to be confusing here because we haven't solved equations, but the golden rule of algebra says that whatever we do to one side of the equation, we have to do to the other. So if I added A to one side of the equation, I would have to add, if I added C to one side of the equation, I would have to add C to the other side of the equation. So again, right now for purposes of the homework, we're going to skip these, okay? You won't have those in tonight's homework. Okay, the other example we have here is the property called substitution. So all substitution is saying is that if A is equal to B, then you can, instead of using A, say I said 3 times A plus 4 times A, we could actually substitute in a B because they're the same thing. Okay, so they're the same. So it can be substituted into an equation or an inequality. Okay, now the field properties are the ones that we are familiar with. So we learned the associative property, the commutative property, identity, inverse, and distributive in the past. The associative is the one you think of parentheses, or you're just changing your groupings. So say I had the numbers 3 plus 2 and I added 4. That would be equivalent to 3 plus 2 plus 4. Okay, so all we're doing is changing the parentheses. So if I actually did this with order of operations, I do 3 plus 2 is 5, 5 plus 4 is 9, and on this side I would get 3 plus 2 plus 4 is 6, and I would get 9. So they're equivalent. So you can change the groupings and get the same answer, and that works for addition, and it also works for multiplication. So you have the associative property of addition, or you could say, well, 3 times 2 times say 4 is equal to 3 times 2 times 4. So if I did this with multiplication, if I did my parentheses first, I would get 6 times 4, which is 24, and here I would get 3 times 8, which is also equal to 24. So your associative property says that you can change the grouping and get the same answer. Now the commutative property actually works with changing the order. So if I took A plus B, that would be the same as B plus A, and that works with numbers. If I said 3 plus 2, well, that's going to be equivalent to 2 plus 3. So 3 plus 2 is 5, 2 plus 3 is 5. So those are equivalent. And that works also with multiplication. A times B is equal to B times A. So with numbers, if I had 4 times 6, that would be equivalent to 6 times 4. Both would be equal to 24. Okay, so the identity property, so we did associative, commutative. The identity property for addition, so the additive, we call this the additive identity. Okay, the addition property of, or addition, I like to call it the additive identity. So call it the additive identity. Just says that if you add 0 to anything, you're going to get the same number. So if I took x and I added 0, I would get x. Okay, if I took 4 and I added 0, I would get 4. If I took b and I added 0, I would get b. If I took 2xy squared and I added 0, I would get 2xy squared. Okay, so if I add 0, I get the same number. So that's the additive identity. And 0 in the case of additive identity, this is called the additive identity element. The element is 0. Now for the multiplicative identity, okay, multiplicative identity, that actually says if I multiply by 1, I get the same number. So if I took x and I multiplied it by 1, I would get x. If I got 4 and I multiplied by 1, I would get 4. B times 1 would be b. Okay, and 2xy squared, if I multiplied that by 1, I would get 2xy squared. Okay, so if I multiply by 1, I always get the same number. That's the identity property. Okay, and that's often confused with the inverse property. All right, the inverse property says that if I add the opposite, whoops, I skipped a page here. Let me go back. Okay, we'll go forward. Okay, so the inverse property says that if I add the opposite, I'm going to get 0. So if I take 4 and I add -4, I get 0. If I take a and I add -a, I get 0. If I take 2xy and I add a -2xy, I'm going to get 0. Okay, again, the 0 is the additive identity element, but with the inverse property, if we add it, we get the additive identity element. So you're just adding the opposite, and that is the inverse. The inverse is like the opposite. Now with multiplication, so this is really the additive inverse. So we're adding the opposite. All right, the multiplicative inverse, all we're doing is multiplying by the reciprocal. Okay, so if I take the number 2, the reciprocal of 2 is 1/2. Remember, reciprocal, you actually take the number and you flip the numerator and denominator, so 2 over 1 would become 1 over 2. That's the reciprocal. I like to think of the reciprocal if it helps you with that word. Anyway, 2 times 1/2 would be 1. Because we go straight across, we get 2 over 2, which is 1. If I had 3/2 times 2/3, I multiply by the reciprocal, I get 6 sixths, which is 1. Okay, and if I had, let me see, any number, any variable, if I took x and I multiplied by 1 over x, I would get x over x, which would be equal to 1. In this case, we're saying that the number, the denominator, cannot be 0 because we can't divide by 0. So multiplying by the reciprocal, you're always going to get 1. And that's the inverse property. So we have the additive inverse and the multiplicative inverse. Okay, and then the distributive property. We've been doing the distributive property. So if we have a number outside of parentheses, say I have 4 times x plus 2, I'm taking the number that's on the outside and I'm multiplying it by every term on the inside of the parentheses. So this would be 4 times x plus our 4 times 2. So that would become 4x plus 8. So we've been doing a lot with the distributive property. We could also say it's maybe a negative 3 times x plus 6. Okay, so this would be negative 3x, and then negative 3 times 6 would be minus 18, so negative 18. So we would distribute the negative 3. So this was kind of a quick overview of the pink sheet that you guys got for homework. I hope this helped. Talk to you later.